Now we're going to have two more shortcuts to getting congruent triangles. The first one is angle, side, angle. The other one's angle, angle, side. So if you remember the notation from the last two, you should pretty much know what these are already. So basically, if we have an angle, a side between another angle, congruent on one triangle to the same thing on the other triangle, then those triangles are going to be congruent. The reasoning for this one, basically, if I've got two congruent angles, the third angle theorem tells me that I'm going to have the third angle congruent. And if I just have congruent angles, that's going to allow me to, change the size of my triangle as much as I want, okay? Because even if I have a small triangle like this, these angles are still going to be the same as the ones I had over here. But that one side length is going to lock me into the right size for the triangle. Okay, so the angles make sure that the triangle's the same shape, and that one side makes sure it's the same size. If you look at angle, angle, side, it's kind of the same concept. The two angles will also give me the third by the third angles theorem, and then that one side makes sure that we have the proper proportion for our sides, so that our sides are the same size. Okay, so you need to have an angle, another angle, and the side in between, or you can have an angle, another side. Okay, as long as the sides are in the same order. So if I had this, okay, I've got angle, angle, so angle, angle, side this way, angle, angle, side the other way. That's still going to work too. So angle, angle, side works, angle, side, angle works. The last one, which is actually 3, is it's the only time that an angle, side, side will work, and we're not going to call it ASS. We're going to call it the hypotenuse leg, because the only time it works is on right triangles. So if you've got two right triangles, and you've got the one leg congruent to a leg on the other one, and the hypotenuse congruent to another hypotenuse, this is enough to know that the triangles are congruent. And this comes right from our Pythagorean theorem. So if I knew what these numbers were, let's say this was A, B, and C, okay, well that means that this is also going to be B, and this is also going to be C. I know that A squared plus B squared equals C squared by the Pythagorean theorem. Well, the only way I'm going to have a length here is if it's also A, because this also has to hold up to that same thing. Okay, because I've got C squared, and that has to equal B squared plus whatever this is. Okay, so this is like my X squared. Or it's actually X, okay? Well, since this equals C squared, and this also equals C squared, I can set these equal to each other. My B squareds will cancel, and then A squared will equal X squared, and the only way that's going to be true is if X is A. So that's kind of a quick proof of why the hypotenuse leg theorem works. So if you've got leg and a hypotenuse on a triangle, congruent to a leg and hypotenuse on another right triangle, those are congruent. Okay, and just a note, if you have, leg and a leg, well then you're going to have side, angle, side, so those will be congruent also. So basically on a right triangle, all you need is any two sides to be congruent. So you need to know the right triangles and the two sides are congruent, and then you can say that the triangles are congruent. So let's review all the tools that we have for getting congruent sides, congruent angles, okay, and then the congruent triangles. And after this lesson, you should be able to dive into those proofs, at least the first few, and start getting some congruent triangles. So, if we want to get some congruent sides, if we're given a midpoint or a bisector, that's going to give us two pieces that are congruent. We can add congruent segments, okay, to get congruent sums. So that would be like, this piece and this piece, and I want to add those up. Maybe that's a side of a triangle. I could say that, okay, so if I've got this and this congruent to this and this, then the whole thing's going to be congruent to this whole thing. So that's kind of what this one is. We've got a lot of things for angles. Parallel lines are going to give us all these special angles, okay, corresponding, alternate interior, alternate exterior. If we get some angles that are supplementary to the same thing, so supplementary to congruent angles, then we'll have congruent angles by the congruent supplements. Same thing with congruent complements. If we have an angle bisector, that gives us two congruent angles. We can add congruent angles together, and vertical angles, which comes up quite a bit.